Hello. Today I'm going to show you how to create an environment for doing work in artificial intelligence. This is going to be an educational video that goes into all of the details that I've learned for how to create a successful environment that can support the workflows of data scientists, engineers, and researchers, and take those applications all the way to production. So let's get started. In today's world of complex software development, you simply need a platform and blueprints in order to accomplish your goals. Many things just aren't possible without one. That's why today we'll be using Openshift. Openshift is an excellent platform for artificial intelligence. Now don't worry, we'll be showing you everything in today's video, including how to create an Openshift cluster. I've been creating Openshift clusters for a while, and so I will show you the best way to set one up that's able to use your GPU in Jupyter Notebooks and provide you with an environment that has everything you need for what I said earlier, for data scientists, for engineers, and for researchers. And then give you that environment that allows you to work seamlessly between development all the way through onto production. So this is the part where we get to work. I might take a seat for a little bit, and a little while we might go back in the back room and I want to show you the machines that I'm installing this on. So as I said, I want to make this a very complete video. And I want to first draw your attention to a Git repository that I created on GitLab. It's public, you can go to this, and it provides you with the general flow of the instructions that we'll be going through today. And you can refer to this as you're watching the video. So you'll notice here the first thing that I mention is you'll need 3 machines. So we're going to create a condensed Openshift cluster. Now, as I mentioned, this is an enterprise level type of environment, but we can condense Openshift down now into 3 nodes for our purposes. And those 3 nodes still need some resources. And you'll see here I've listed just as a general guideline. These aren't hard and fast, but you want to have enough to do what you want to do. And I've listed that each machine should have 16 cores, 128 gigs of RAM, and 1 disk for the operating system, and extra disks totaling 4 terabytes that are extra. And the reason for this is we're going to be installing Open Data Foundations, or what used to be called Openshift Container Storage. And it does take a decent amount of resources to run that, but it makes persistent storage and work with persistence so much easier in a container platform like Openshift that it's well worth the extra resources that you're going to be needing. One of the really nice things about Open Data Foundations is you don't need to be a storage expert to create really good storage for Openshift. And you'll have access to 5 different storage classes, and it creates, out of the disks that you've put into each machine, it finds them and can create this hyper-converged storage for you. And as I mentioned, you don't have to be that storage expert to accomplish a task. One of the lessons that I had to learn the hard way is make sure that you clear all of the disks. You'll see here in the second step, clear all the disks of any partitions and put enough disks in each machine for Openshift Data Foundations, what used to be known as Openshift Container Storage. So I prefer to have extra disks for at least 4 terabytes of Openshift Container Storage. If you have it, you can put more disks in. And one thing to remember about Openshift Data Foundations is it automatically replicates your data for you. So you have a copy on each of the 3 nodes in the cluster. So if you want Open Data Foundations to have 2 terabytes of storage, then you'll need a total of 6 terabytes. So you'll need 2 terabytes on each machine. But it's very important to ensure that you clear all of the disks of any partitions. You can, I prefer to do it up front. If you don't do that up front on your extra disks, then yeah, you can take this other approach that I've listed out here of going into OC debug node and then the node name. And OC is a command line tool that allows you to work with nodes and objects within your Openshift cluster, and you'll become more familiar with that if you're not already. So that's step 1 and 2. So create your machine, get the 3 machines hooked up, and then clear all of the disks that you're putting into the machines. So let's go on to step 3 here. This really is one of the only prerequisite housekeeping steps that we have to perform, and in it I say configure HA proxy with haproxy.cfg. What we're doing in this step, if you were to look at the documentation for how to install Openshift, you'll see a lot of different options. We won't go into the details of IPI versus UPI, but what we're going to need is similar, even though we're just installing on bare metal. It's similar to the simple prerequisites for vSphere. We'll be using assisted installer, and we'll go through that process. And the only prerequisites that we require are similar to this that you see on the screen: 2 DNS records, 1 for the API and 1 for the ingress. I take a little bit different approach, and I include a file in the repository here. I have an haproxy.cfg, and I have multiple clusters in my room behind me, and so I need to be able to allow external public domain names to reach all of my different clusters. So I have a load balancer inside my office here that I direct traffic to, and that's the thing that directs traffic to the cluster. And I have entries in the load balancer in that haproxy.cfg for these 2 things. And you can take a look at the file, and I'll just open that up. And in here you'll notice that, so I've replaced the domain names that I use with just some generic domain names. Domain 1, domain 2. I also have entries in here if you were to create your own routes that used your own custom domains. I have an example of how to do that in here. But I have entries for both the API and the ingress. So the main thing that you need when you're installing, so when you're doing what we're going to be doing, assisted installer, you're going to assign IP addresses via DHCP. So the machines that you're going to hook up, I've got 3 of them, they'll assign their IP addresses via DHCP. However, you'll want to allocate IP addresses in the same subdomain but outside of the automatically assigned range. So if you had IP addresses that went from 192.168.50 to 200, then you would want to include in your subdomain the IP addresses like 192.168.201 and 202, so that 201 and 202 would be outside of the automatically assignable range, and then those are the IP addresses then that you could use inside this file. You'll notice that I have some hard-coded values in here, and those will be for your ingress as well as your API. So then I've got an API IP address and an ingress IP address. So that's really the only, I'd say, not really complicated things, but get that prerequisite right up front, I include this file, and you can either do it through your DNS settings or do as I do, just install HA proxy, drop in this example file, and then just modify it for the IP addresses that you need, that you've chosen for your ingress and API, and then your domain names as well. All right, with all of that now out of the way, we are ready for step 4. Go to cloud.redhat.com and follow the assisted installer instructions. I'm just going to go to cloud.redhat.com, put in my credentials, I'm going to hit login, and over on the left-hand menu, you'll see Openshift. Click that and go to Create Cluster. We're going to be creating this cluster on-prem on bare metal. No virtual machines, no vCenter, no nothing, just are my bare metal machines behind me. So I'm going to click on Data Center, Create Cluster, and then it automatically assumes assisted installer. So assisted clusters, and you give it a cluster name. So OCP AI. So let's take a quick segue over to Route 53. I put my cluster name in, and that's relevant to what I've done in Route 53 here because I have 2 entries here. These are the only 2 entries that are relevant to today's video, but I have an entry for the URL that is associated with my API, as well as the URL that's associated with my ingress. And those are configured in my HA proxy configuration. So I have put these entries in, and they will point to my load balancer. And when the load balancer gets requests from these addresses, URLs that match these addresses, then my HA proxy configuration sees that and routes the traffic accordingly. And then my public domain name, because I like to be able to access my clusters publicly wherever I'm at, and I own domain name in Amazon. It's enterprisewebservice.com. All right. And I'm not going to be doing single node OpenShift. That is an option. If you didn't have 3 machines, you could install OpenShift on a single node. That would not be my recommendation for doing artificial intelligence, however. So I'm going to select the latest and greatest version 4.8.2 and click Next. This is where we click this big blue button, say Generate Discovery ISO. And what we'll have to drop in here is my public SSH key. And I'll be using then a key that, so I've got here, let's see, okay, and generate. So the reason you put that in is so that you can log in and do troubleshooting if there are any issues. You can log in directly to the nodes of your cluster using your private SSH key that's associated with that public key. Once that discovery ISO is generated, you can download that file. So I'll download it. It'll take just a little bit. And once we have the ISO file, I've got 3 USB devices here. So I'm going to take that ISO and put it on all 3 of these ISOs. You could do it with, a Pixie boot loading. You could, a lot of my servers back there do have the ability to attach ISOs via the network, but because I'm in the office here, I find it just really easy to download this image and then burn it to my USB drives using Rufus. So using this file here, or this tool here. Once that finishes installing, that's what we'll do. Now that we've downloaded the image, let's bring up Rufus. I'm going to select that image that we just downloaded, click open and hit start. You'll want to use write in DD image mode. That just works better. If you use ISO mode, a lot of times you'll boot the machine up and for whatever reason there will be an error. You won't get that problem if you do write in DD image mode. Let's hit OK. It will of course wipe out anything on your USB and click go ahead, and once that image writes, I'm going to do this process 2 more times, and at that point we'll be able to start the actual installation. Okay, now that I have my 3 USB devices with the Discovery ISO on them, I'm going to put them into the machines that will make up our cluster. So I've got multiple clusters running, but the 3 machines that are going to be running this cluster are right here. So I have Threadripper Pro on the left, just some standard consumer grade machines on the right, and you'll notice that they're all quite different. That's the nice thing about Openshift, is you can use some heterogeneous compute and storage, and Openshift will know how to take advantage of it to the to the best of its ability. So now let's go ahead and take a look at what we have in our main kind of powerhouse computer here. So you'll see that I've got SSD, I have NVMe's, and then on the back side I have SSDs, but this is the machine that has our 3080 in it, and all I have to do now is just pop in the USB. So I've done that over here. So I've got that, just all you have to do, plug that USB in the back. That's going to be what we're going to boot to. And I'll do a similar type of thing to this machine here. And this machine here. So let's go ahead and put that in. All right, we just have to turn these guys on and boot up to those devices, and I'll show you how that works in the assisted installer here in just a minute. All right, we're back. I have a KVM over IP that allows me to more easily share what's happening on these devices. So I've just booted up the Threadripper Pro. I'm going to hit F11 so I can get the boot menu. I'm going to be doing something similar to each one of the machines. Alright, and I'm going to look for my scan disk, or my SAN disk, the USB device. Alright, so I'm going to select this and start the boot process. So Red Hat CoreOS will boot up, and you should, after it boots up here, you'll see what happens. Once that finishes, we'll go back here. That sometimes can time out, but I'm going to go back to my clusters, my assisted installer and clusters, and hit next. Now it's waiting for hosts, and once our machine looks like this is what you would expect. It should appear in the list, and there it is. So automatically, that's pretty nice. You didn't have to install anything. You just go to cloud.redhat.com, generate the ISO, and put it on the USB stick, stick that in, and we'll do that 2 more times now. So I'm going to turn the other machines on. So I just turned this machine on. It boots up and automatically is discovered by cloud.redhat.com. All right, all 3 machines have booted up with their respective discovery disks attached, and they automatically appear in this list. I've already modified the host name of this one, but what you'll need to do is make sure that each one has a unique host name. Localhost is not allowed. If you don't see the 3 dots on the right hand side, the screen size sometimes is just right where you can't, so I'm going to modify that. I'm going to click this, click edit host. So I named the first one master 1, I'm going to call this one master 2, and the third one master 3. Again, I'm creating a 3-node cluster. In a full Openshift cluster, you would probably want to separate both your worker nodes and your master nodes. But in this, I'm allowing everything to get installed on 3 nodes, so they'll kind of pull double duty. They'll act as both worker nodes and master nodes. And automatically, when you just have 3, the assisted installer knows that and accordingly creates both that worker node and master node configuration on just those 3 machines. It appears, after changing the host names, we're ready. You can see the CPU and memory and disk space that we have available on each of the machines. And so I'm going to go ahead and click Next. The next thing that I want to do is I don't want to automatically allocate those API and ingress IPs by a DHCP. I want to manually assign them based on what I have configured in my HA proxy. And I'm just going to go back in here to refresh my memory. So I'm using 220 and 221. So 220 and 221. Here, and I'm going to say this, and I'm going to select this subnet. I'm going to say 192.168.1.220 for my API, and 192.168.1.221. It's on the same subnet as the machines that are on your DHCP subnet that will be assigned to your nodes, but these 2 IP addresses need to be outside of the DHCP assignable range so that they won't be taken, and they can be used automatically by the installation program to configure the API and the ingress VIP. All right. Let's hit next and install cluster. Now everything is pretty much automatic. You can just sit back, grab a cup of coffee, come back after maybe 30 minutes, 35 minutes. It can take longer or less time depending on the speed of your hardware, but you pretty much don't have to do anything. Everything will be done for you. All right, we'll come back after this is done installing, and we'll move on from there. That didn't take too long. We started that at 5:43 and it is 6:15 now. And so we have a cluster. It's fully installed and ready to go. What's nice about cloud.redhat.com is we can see our handy web console URL. We can go ahead and click that. It will bring us to our console. It also has our kube admin and password. I can go ahead and just copy that. And log in. There's just one more operator that is updating. That should finish soon. But for the most part, we have a fully operational cluster. The next thing that we're going to be doing in our list is number 6. Once the cluster is installed, let's set up Openshift Data Foundations. That gives us the nice storage classes that we can use for our registry. One of the things that is kind of a sticking point for a number of people is a registry that requires read-write many storage, and right now some people, they like the easiest a lot of times is NFS storage. I don't like that. It's not really good for production at all. And OpenShift Data Foundations makes that really simple. You get read, write, many storage, and it will be available to you for use in your registry. If you don't already, you will need to install the OC command line tool. That's not something I'm going to go into detail on how to set that up. That's really easy. Just if you don't have it or have never set it up, just download the OpenShift command line tool, and what you'll do is download your kubeconfig, and if you're on a Windows machine, you'll create an environment variable for the location of your kubeconfig file, and on a Linux machine you would update your bash profile accordingly. But all of that you can find. We don't necessarily need to go into that. With that kubeconfig file in place, we can start up command prompt, and we can just type OC get nodes to make sure everything's working, and it is. So all of our nodes are ready. As I mentioned, they're both masters and workers, and I have some instruction in here on what to do. So we're going to enable, we're going to install ODF. First thing we need for that, I'm going to basically go to operators, go to operator hub, and type in container storage or something like that. So we have OpenShift container storage is the operator that you'll use. This is an operator that I never have fail on me. As long as you've cleared your disks, the extra disks that you have on each machine, you can pretty much just use this. It will find the internal storage and work. So I'm going to go ahead and install this. I'm going to install the stable 4.8 version, and I'm going to leave the defaults here. It will install into the OpenShift storage namespace. I'm going to also approve update approval to automatic. Let's go ahead and click install. It'll just take a minute or so to install the operator itself, and from that point we'll use the operator to create the custom resources for OpenShift Data Foundations. Alright, the operator is installed. Let's go ahead and create our storage cluster. We've jumped over into the OpenShift storage namespace, and I am going to use the internal attached devices. Click install, and we're going to do local storage. So we have to first install the local storage operator, and you can install that separate, but I am going to take the recommended settings. It'll create an OpenShift local storage namespace. Let's go ahead and click install. Okay, we have the local storage operator installed, but let's go back to our OpenShift storage namespace. And if it's hard to find just by searching through the list, we can always just type it in, OpenShift storage. Click there, go to installed operators, OpenShift container storage, and I am going to create storage cluster. So create storage cluster, kind of where we left off before. So because I didn't have the local storage operator installed, it jumped me out of this process and installed the local storage, had me install that local storage operator, because that's what it'll use for the internal attached devices option. And I'm going to just say disks on all 3 nodes. And let's go and hit next. So local volume set name, we can give it any name that we want. Let's say my ODF storage, and I'm going to say disks on all 3 nodes, or disks on selected nodes, but I'm going to say disks on all 3 nodes. If there's any advanced settings that you would like to modify, you can. I'm not going to. I'm going to click next. Yes. Sometimes it just takes a little bit of time for the nodes to appear in this list. If they don't, you can click this link and then click back to this link and they will appear. Now it looks as though the available capacity that I have is 13.86 terabytes. Right, that sounds all right. Let's go ahead and click next. I'm going to just keep the default software-defined network. Click next, and all right, and I should be able to just go ahead and hit create. So that's the nice thing about OpenShift operators in general. Which is step 7. We need to get the registry that stores our container images. So OpenShift comes with a container registry built in that facilitates things like CI/CD, and that's what we'll set up next. Now that we have that read-write access, read-write many OpenShift storage available to us. So that's what we'll do now. To create the registry, we need to go to the registry namespace first. Let's go up to projects and search for registry, and then you'll see the OpenShift image registry namespace. We'll create a persistent volume claim, and that persistent volume claim will have at least 100 gigabytes of storage, and I'll just name it my registry claim, and I'm going to make this read-write many, so RWX. And you can, what's nice now is just select the storage class that you want, and we're going to use the appropriate one for the registry is going to be OCS Storage Cluster CephFS. That was one of the storage classes that was created by Openshift Data Foundations or Openshift Container Storage. So click that, and we're going to set this to be 100, and go ahead and hit create. And right away we have it, looks like it's successfully bound now, and it has 100 gigabytes of storage. And the next step we need is to go to the command line, and let's take a look at the instructions. I have them in the Git repository. So we'll do OC edit. So that command, we're going to run that. And I'm on a Windows machine. If you're on a Linux machine, it will come up in your editor of choice there. But so let me just make sure before I do this, I want to go to OC project. Let's make sure I'm in the right project. So OpenShift image registry. Let's go to OC project OpenShift image registry. Now let's run that same command again. And we're going to change this management state from removed to managed. And then we also need to change the storage section here, get rid of those empty brackets, and then we'll create an entry just like you see here. So copy, and I'm going to put that into here. Let me get rid of this. And then if you don't remember what it was, so it's my registry claim. So I'm going to replace the PVC name with my registry claim. Save, and that should automatically, when I close this, so it's been edited, and when we go and look at the pods that spin up, you'll see that there are now, so there's an image registry that is backed by persistent storage now. All right, so we're done. We have an image registry, and we can move on to the next step. And that next step is we need to entitle the entire cluster with a subscription. And that's in order for our Nvidia driver to be able to come up, because it requires a subscription in order to do that. So we'll do that next. We need to get a valid subscription file, so your PEM file for a system. You do that by going to access.redhat.com under subscriptions, and then take a look at the Systems tab, and find a system that has a valid subscription attached. You'll click on the link for that system, go under Subscriptions tab again, and then you will click on the Download Certificates button. So just click that. It will give you a zip file, and in one of the folders in that zip file you will see a PEM file that has the subscriptions, the certificates that you need. And then once you have that, you can take and move that PEM file over into, now preferably the next thing that you'll be doing a command that requires Linux. So do this on a Linux machine. Get that PEM file onto a Linux box where you can run, or a Mac where you can run a Unix command, and then make sure, if you haven't already, that you've cloned the repository. So my public repository here, I'm going to take that and clone it. So git clone, and then I'm going to move that file. So copy, or I'm going to copy 2.4 into my public, and so 2.2.4.3. All right, and then we'll go into the public setup AI folder from our cloned repository, and you'll see that we have a template in here. Now this template is something that you can find. I believe I have the link in the instructions. If I don't already, this template comes from instructions that are in a blog post for how to create a cluster-wide authorization. So you're going to basically have subscriptions be available cluster-wide to your Openshift cluster. And there's a blog post. I will add it under the Untitled Cluster instructions, and that's where you'll get that template, or you can just use the template that I have. I've also checked it into the repository here, and it will be in there. So this isn't, this is something that is sanctioned by Red Hat, and we have a template that can allow you to do a command, and that command will get your subscriptions into the right place. So just copy this in the instructions that I have online, and then we'll replace that ID with the name of the file that we've created. All right, go back here, and then I'm going to come back and change the ID to be 2.4.3. Go ahead and hit enter, and that will output a file without the .template. So we should see that in there now. So we do, and we can just go ahead once we're going to want to actually create so do OC create inside. So it doesn't really matter where we're at, but we're gonna, because if you look at the template, let's go ahead and take a look at the template. Then we'll be creating machine configs, and what a machine config will do, it's a way to update the operating system. Openshift's operating system is immutable. You can't just log in and make changes, because the OpenShift system itself will revert those changes. It's much more secure that way, much easier to do updates. But if you do need to do a change like this that is kind of at the operating system level, then you can make a change via a machine config, and that will get applied to nodes that are labeled accordingly. Now, if you're following the instructions that come from a different place, it will apply these machine configs to master, to the worker machine config pool. But because we have that condensed cluster of 3 nodes, the machine config pool that we're using, so if we take a look at this, OC get MCP, we have 2 machine config pools, but our machine count, the only machines that are in a pool are in the master pool. So that's why in here we have to label the machine config as such, so that when we apply it, it will get applied to the masters. And then anytime you make a change like this to, with a machine config, the nodes do reset. So they'll get restarted, and when they come up, your changes will be in place. So to make those changes, I'm going to go ahead and say, do an ls on the file that I'm interested in. So we've got that 003. So we're going to say OC create -f and do 003.yaml. And it went ahead and created these entitlements, and we'll see that if we do OC get MCP again, eventually what will appear here is updating will turn to true, and one by one each of the nodes will get updated and reset, and then the machine ready count should be 3 again. So we'll come back after that's all done and move on to the next step. The nodes have all restarted automatically now, and we have a cluster that has a cluster-wide entitlement so that we can run commands that require a subscription, and we need that for the Nvidia operator, the Nvidia GPU operator. Before we do that, though, we're going to go on to step 8 and install the node feature discovery operator. We do that by coming into the operator hub. We type in node feature. So we actually want the one that isn't community. It doesn't have an icon for whatever reason. By the time you do this, it will. That's just probably something temporary in 4.8. So let me go ahead and click install. And I'm going to do this for all namespaces. Just keep the default. Okay. And we will wait for the operator to finish installing. We'll need that to install some custom resource definitions that are associated with it. Now that it's done installing the operator itself, let's go to view it. Let's go to node feature discovery and create. And we can just keep the defaults here and just go ahead and hit create. Once that finishes, we can move on to step, is it 9 or 10, install the Nvidia GPU operator. And we'll do that next. Okay, with all of the node feature discovery operator pods running, we will go back to the operator hub, just type in Nvidia. The Nvidia GPU operator will appear. Let's go ahead and install that. And keep the defaults once again on all namespaces and install. And we'll give that a minute, and once we have that, we will be able to create some custom resource definitions that will spin up an Nvidia driver pod that is the thing that requires the subscription, which we've already enabled. Okay, with the operator installed, we can go view it, and we're going to create a cluster policy. Click create cluster policy and just keep the defaults. Go ahead and hit create. So let's take a look at the pods that will be coming up, and we'll to see what it's actually creating, we'll need to go to the GPU operator resources namespace. And this is the key down here, the Nvidia driver daemon set. That's the key pod that we need to have running. So it'll take some time for all of these pods to come up, but when they do, we're ready to install Open Data Hub after that. All right, that won't take long, and it's very important that you double check in the GPU operator resources namespace that all of these pods are running, especially the Nvidia driver daemon set. So with the node feature set and the Nvidia GPU operator installed and working, go back to the overview and then double check in your nodes that your nodes have been labeled. So if you have a GPU in one of the machines, and the machine that has the GPUs in master 3 here, the label should exist that tells it that a GPU is available and present on the machine. So let's take a look at that. Let's go into details, take a look at the node labels, and somewhere in here you should see an Nvidia GPU, and we do. So we'll see that it's a GeForce RTX 3080. So that the label is there, and then when we spin up Open Data Hub, we'll have access to that GPU for doing work with artificial intelligence. Okay, we're almost all of the way there. The next thing that we have to do is install Open Data Hub. Open Data Hub has all of the components that we need for doing work with artificial intelligence in a Kubernetes cluster using Openshift. I have some instructions here that will help you do some configuration to take advantage of the storage cluster that you've already installed. We'll need to go back to Operator Hub and type in Open Data Hub. Find the Open Data Hub operator. So that's what's nice about Openshift and Operator Hub. It's a lot like going to the App Store and grabbing what you want, and it makes it pretty simple to spin some pretty complex things up. In this operator, you'll see a list of software that, if you're working in AI, probably looks familiar to you. What this operator does and what Openshift does is it makes it easy to get all of these things installed, and installed in a way that makes it possible to work seamlessly with other researchers, data scientists, and even the engineers that will take your application and your ideas all the way to production. Okay, let's install it. We will use the defaults again and click install. It will take a couple of minutes, and when it's ready, we'll move on and create the custom resource definitions, the custom resources that make it easy to create all of those applications that are on the list. All right, let's view the operator. Let's go to the Open Data Hub tab, and it says Create KF Definition. We'll click Create, and then go to the YAML view, because we're going to modify it slightly so that we can take advantage of the OpenShift container storage that we've already created, as well as let's pare this down. Now, we could just click Create and it will spin up everything. You can do that once you have your own environment up. I'm going to, for the sake of this video, show you just spinning up the Jupyter Notebook backed by a GPU. To do that, I'm first going to remove everything from this list under Applications for everything else except for the Jupyter Notebook sections. All right, so we'll do that. And I'm going to take this out. And I'll leave that, but I will take out Airflow. And the ODH dashboard. I'm going to take all of that out. Okay, now go back to my instructions, and I want to make my section with this section look like this and take advantage of the storage class that we have access to. All right. All right, that goes under Overlays. Storage class, and then under parameters, okay, we'll need to make one more change, and that change is to enable the GPU images to appear in your Jupyter Hub that you can select from. To do that, one of the things that I include in my documentation is this link. This link goes to a GitHub repository, and it lists out the various overlays that you can include for your notebook images. And I find that just using CUDA doesn't necessarily work for me because I have a very new graphics card, so I have the 3080. Because I have the 3080, these images use a much newer version, well, not a much newer version, but a newer version that the images, they just seem to work better. So if at all possible, get the latest graphics cards you can, and then enable CUDA-11.0.3. To do that, I will show you how. We just have to add this option in the overlays section. All right, let's come back here. Just hit enter and paste. Now there is one more thing to mention. It may already be fixed by the time you watch this, or it may already be fixed now, but what I ran into the first time that I installed this is when you enable CUDA, then it generates, so I'm going to go ahead and hit create and come down and look at our build configs. So it creates these build configs and a number of layers so a number of images get created in layers. And now that these build configs are in place and have triggered the builds, you need to come back so that you need to go back and take a look at our installed operators. Go back into the Open Data Hub. So the KF definition that you just created, go back into the YAML and now remove that CUDA overlay. And this is to prevent it from going into kind of a never-ending loop of triggering those builds. What I noticed before is it would trigger a build, finish that build, and then start that build again. But when you remove this, because really all you needed it to do was trigger the build configs to be created and hit save, then that won't happen. So that's an important step if you do run into some issues building your image layers. Taking a look at the builds that are running, we've already built 2 layers. The third layer is being created, but we're going to have to create a layer for each one of these build configs. So that's what these build configs will trigger, is a build for each one of them, and that can take up to about 40 minutes depending on your Openshift cluster. And once that's complete and we have our TensorFlow GPU CUDA image, we can then go into our network settings, take a look at the routes we have, and click on this route, and we should see the GPU enabled image that we can select. We are at the moment of truth. All of our builds have completed. We have our TensorFlow GPU CUDA image. Now we can take a look at our Jupyter Hub to see that the images we need are actually there. Let's go to our routes, click this, and we can log in with the same credentials that we logged in using to log into Openshift. It allows selected permissions, and we have our Jupyter Hub and a number of images that we can select from. I am going to select TensorFlow CUDA 11.0.3, and I'm going to select large size and start server. And it will take a little bit of time for that to come up. Once it does, then we'll look at our Jupyter Notebook and run a command to double check that we have access to our GPU. When it comes up, it looks like this. Automatically, it transitioned into this screen. I'm going to select Python 3, and I'm going to run a check just to make sure that we have what we need. So I have this in my instructions at the bottom. So it says spin up a notebook using TensorFlow or PyTorch and run the following to see that you have access to a GPU. So I'm going to copy that, paste it in. You don't have to do anything to have access to TensorFlow. The image that we created and selected has those things. You just have to import it and use it. Let's go ahead and run this. And we see that the number of GPUs we have available is 1. All right, we have successfully created an environment now, and you can go back to the KF definition that we created and include those other components for whatever you need to do. All right, we are off to the races. You should have everything that you need to start your journey in artificial intelligence on top of OpenShift and Kubernetes. And there will be further videos to come. I want to thank you for joining me today, and stay tuned.